Welcome to NASA's Stennis Space Center near Bay St. Louis, Mississippi, and the live broadcast of today's scheduled RS-25 engine hot fire on the Fred Haise Test Stand. Operators and engineers are testing RS-25 engines here to help power human missions to deep space as NASA explores the secrets of the universe for the benefit of all. Four RS-25 engines manufactured by lead engines contractor Aerojet Rocketdyne help power each NASA Space Launch System rocket at launch. NASA has designed the Space Launch System rocket to fly astronauts and cargo on Artemis missions to the Moon and eventual missions to Mars. Each RS-25 engine used to help power Space Launch System missions is first tested and proven flight-worthy at NASA's Stennis. Developmental testing for new RS-25 engine components and performance parameters also is conducted at the center. To date, NASA Stennis has tested RS-25 engines for the first 4 Artemis missions. NASA Stennis tested the 4 RS-25 engines that helped launch the successful Artemis 1 flight around the Moon and back in late 2022. NASA Stennis also has conducted RS-25 developmental testing as Aerojet Rocketdyne prepares to produce new engines to launch missions beyond Artemis 4. Aerojet Rocketdyne is using manufacturing techniques such as 3D printing and state-of-the-art components to reduce production time and cost for new RS-25 engines. Today's hot fire is one in a series of certification tests of an engine manufactured with new processes and components. Certification tests will help demonstrate Aerojet Rocketdyne is ready to move forward in producing RS-25 engines for future Space Launch System missions. During today's test, operators will fire the RS-25 engine for about 8.5 minutes, or 500 seconds, the same time engines must fire during an actual launch. The RS-25 engine will power up during the hot fire to the same level required during a mission launch, producing up to 418,000 pounds of sea-level thrust. At altitude, the engines produce as much as 512,000 pounds of thrust each. RS-25 engines are fired using a mix of liquid oxygen and liquid hydrogen. Liquid oxygen and liquid hydrogen are cryogenic propellants that must be stored at super cold temperatures. Liquid oxygen is stored at -280 degrees Fahrenheit. The temperature for liquid hydrogen is even colder, measuring about -420 degrees Fahrenheit. Propellants for a hot fire on the Fred Haise Test Stand are provided by a 40,000-gallon liquid oxygen tank and a 110,000-gallon liquid hydrogen tank located atop the stand. Fully loaded, the test stand propellant tanks can power a 350-second test. For hot fire tests longer than 350 seconds, like today's is scheduled to be, additional propellants are delivered by transport barges docked nearby. The docked barges are connected to the test stand cryogenic piping systems. In addition to propellants, operators flow as much as 170,000 gallons of high-pressure water to the test stand during each minute of a typical hot fire. Most of the water flows from the NASA Stennis high-pressure industrial water facility to protect the test stand flame deflector from damage by the super-hot engine exhaust. The pressurized water sprays into the flame deflector through thousands of holes strategically designed to direct the water spray where needed. The high-pressure water mixes with super-hot exhaust to produce a massive steam cloud seen exiting the test stand during a hot fire that is often mistaken for smoke. This steam cloud billows into the atmosphere and, depending on conditions, can condense and fall as raindrops in a very limited area. The steam cloud phenomenon gives rise to periodic and erroneous speculation that NASA actually has a rain machine. As one would expect, safety is a prime concern during all hot fire activity. No personnel are allowed on the test stand immediately prior to and throughout an RS-25 engine test. Operators and engineers conduct the hot fire from a fortified test control center located a few hundred yards from the stand. NASA personnel also have established boundaries for viewing RS-25 engine tests in order to ensure the safety of observers in the event of a hot fire anomaly. Throughout the day, operators and engineers have been working through a lengthy pre-test checklist of preparatory steps and activities. NASA is committed to testing like you fly, which means the pre-test process mirrors the one following in preparing for an actual vehicle launch. Teams now are approaching final preparation for today's test. Please enjoy today's certification hot fire of an RS-25 rocket engine on the Fred Haise Test Stand at NASA's Stennis Space Center. Stay tuned following the test for updated information and a chance to view a NASA Stennis video titled Part of Something Great. A hot-fire test of an RS-25 engine is scheduled to begin soon on the Fred Haise Test Stand at NASA's Stennis Space Center. Please stay tuned. This concludes the live broadcast of today's RS-25 engine test on the Fred Haise Test Stand at NASA's Stennis Space Center. Please check the NASA Stennis website and social media channels for additional information about today's test as well as upcoming hot fires. Thank you for tuning in and for your ongoing support of NASA and NASA Stennis. Please join us now in viewing a NASA Stennis video titled Part of Something Great.
You have probably driven past it, seen the name in the news, perhaps even met someone who works there. But what do you really know about NASA's Stennis Space Center? There are a lot of facts, but here is the important one. This nation is headed to deep space, back to the moon through the Artemis program, including with the first woman and the first person of color, and then on to Mars. The country has put its trust in NASA's Space Launch System rocket to fly farther than ever before. And like before, Stennis is testing the very rocket stages and engines that will help launch those deep space missions and send astronauts to other worlds. This is what we do. We help power space dreams, right here in Mississippi, right in our own backyard. That makes each one of us part of something great. Go NASA. Go Stennis.